Okay, let's give you guys some practice. Your job here is to differentiate this. Okay, find the derivative of inverse sine of x. But before you do, look at this. This is your normal standard y equals sine of x here. Because we're interested in y in this graph here, because we are interested in this, we will need to reflect this along the y equals x line. So the height, bear in mind that the height here, it is the highest point will be 1, and this here, the lowest point is -1, and the cycle here, this bit here is pi over 2, this bit here, it is negative pi over 2. So at the moment, this is your standard y equals sine of x. Okay, but we are interested in y equals the inverse sine of x. So we will need to reflect this along the y equals x line. So now I'm going to reflect it, and it will look like this. Hang on, reflect it, it will look like this. So this now, so at the moment you've got a graph of y equals the inverse sine of x. It will look like this. But then this is not a function, because a function, if you draw a vertical line here, a function will only give you one value. Here it's giving us 3 values. So at the moment it is not a function, but we can cast it into a function we can turn it into a function by just restricting it to within this area here. Okay, so we are going to discard everything else out here. We're going to discard everything else out here. We are going to discard everything out here, even though there's nothing out here. We are just going to be looking at this bit here. Okay, but now you can see it's a function, because if you draw a vertical line here, you've only got one value here. You draw a vertical line here. You see, by us restricting it to within this region here, we've created ourselves a function. So this now is a function. So hang on. So your inverse sine graph will look like this. So when people talk about the function inverse sine of x, you should picture this inside your mind here. It only goes from here to here. So the domain. So when someone talks about the inverse sine of x, you should be visualizing this inside your mind, just this region. So the domain here, -1, the domain is -1, this is positive 1 here. The range here, the highest point here, it is pi over 2, the lowest point is well, anyway, when someone talk about the inverse sine of x, picture it as this inside your mind. Okay, so now it's your turn to have a go now. Hang on. So your job here is to find the derivative of the inverse sine of x. Okay, so press pause and have a go. Okay, so to do this here, starts with this, and then starting from here, sine equally to both sides. So that would then give you this. Okay, and then here visualize it as well. Bear in mind that y here is a function of x. So here you've got to use a chain rule. So use implicit differentiation here. So differentiate sine of y. That will then give you this, and then you've got to times dy by dx, which is y prime here. Well, anyway, from here use implicit differentiation to take you to here. Okay, so now you've got one bubble here multiplying with another bubble here. Your job is to isolate this, get it on its own. So in your mind, divide both sides by this bubble here. So divide both sides by cos y. That will then give you this. So you see, this here is your final answer. But the thing is, it looks quite ugly, because you want the answer in terms of x. You don't really want y floating around in there. So remember that trick that we use. We started this here was a question. Find the derivative of this. Sine equally to both sides, then that would then give you this. Remember that trick that we use. Starting from here, translate this into your right angle triangle. So remember, this here is sine y equals x. Sine y equals x. So just translate this into that right angle triangle. So sine y equals x. Hang on, sine y equals x. So looking at this here, right angle triangle, sine y equals x. So now, so remember, our final answer our final answer was this: y prime equals this. But we don't want y in here, so we're gonna change this bit here. Well, anyway, remember sine y equals x here. Translate this into a right angle triangle like this. So sine y is always opposite over the hypotenuse. So looking at this here, you want to translate this. So somehow create the x. So sine y will somehow create this x here. So if you make this length here to be x, and then this length here to be 1, then you will create yourself sine y equals x. So let's just say this length here is x. Let's just call it x. Okay, so here sine y, and then sine y will always be opposite over hypotenuse. Well, opposite is x, and then we deliberately we deliberately choose this here to be x and this here to be 1. So by looking at this here, we've translated it into this. Okay, so at the moment it's sine, but then we can translate this in terms of cos of y. So looking at this triangle here, remember cos will be this thing here. So cos of y will be this length here. Well, this length here by using Pythagoras. Remember Pythagoras. It will be this length here will be root hypotenuse squared, which is 1 squared. Take away x squared here. So this length here is root 1 take away x squared. Okay. Well. Look. So now this length here is root. So cos of y is root 1 minus x squared over the hypotenuse, which is 1. So this thing over 1, it is just so because this thing's divided by 1, it just simply stays as 1 minus x squared. Okay, so cos y equals this thing here. So you see earlier we started with sine y, and then we translated it to cos y. So you see we can actually now put this into this thing here. So the derivative, hang on. So cos of y equals this. So we can now put it into this thing here. Cos of y equals that. So we can now put this into there. Okay, so now we just found out that cos of y equals this thing here. We can put it into that thing. So now it's y prime equals this thing here. So this here is your final answer. Okay, so your final answer is this here. And then just to double check, if you get a graph plotter and plot a graph of y equals inverse sine of x, or sometimes you might have to write this arcsin of x into a graph plotter. It will then give you this red line here. Okay, and then if you plot a graph of y equals this thing here, it will then give you this blue line here. And then have a quick glance. When you're here, notice that the gradient is positive and it's really steep. So it's positive and really steep. Okay, and then here it's still a gradient here. There's still a gradient here, and there's still a gradient here. And then when you reach towards here, it's really steep and it's positively steep. So look, up here, it is really steep and positively steep. Well, anyway, by glancing at this, you know that this here, it makes sense. So you have a gut feeling that it will be right. If you get something like this, I don't know, if you get something like this, then it wouldn't be right, because when you're here, then the gradient you would expect it to be positive, because, well, anyway, by glancing at this, you can have a gut feeling that this here is probably right. Okay.